This lesson is going to move our knowledge of surface area beyond cones into different shapes, and today we're going to be looking at pyramids. Now, pyramids would either have a triangular, a rectangular, or as we'll see in the last example, a pentagonal base. So it's sitting on something, but all the sides come to one point, which is called our apex. Right up here, this is called the apex. All these sides come to that point, and we can see the sides on a pyramid are all triangles. So what we have to determine is when we're looking at the surface area of a pyramid, how many triangles are we looking at? Are these triangles actually all the same size, or are some different sizes? And then we have to read the question and determine if we're actually including the base or not. Now, we'll start with this this pyramid, and it's saying find the surface area of the square base pyramid. So if I look, there's the square base that's 24 by 24, and then there's the 4 triangles that make up the other part of it. So we have to add up all of those sides. So there's a base and 4 triangles. Then really, I'm talking about 5 separate faces that I need to consider in this calculation. We might as well start with the bottom. It says it's a square, so the bottom is 24 by 24. So if we take length times width to find the area of the bottom of this, that's 576, and in our case, square meters. We'll worry with the units at the end of the lesson. Now we're going to look at the triangles that make it up. Since it's a square pyramid, all of the triangles have a base of 24, and the heights will all be the same on here as well. So what we have to look at is then, do we have the base of the triangle with its height? Because the formula for a triangle, the area, is base times height divided by 2. Now back in our other lessons, we said base and height need to make a 90-degree angle, which this actually does. One thing you really want to be careful with is the diagram giving me a height that's actually on that triangle? Or if I just scroll down to this next example, we can see I have a base still of 24, but my height isn't indicated. My height's actually inside the pyramid. So we're going to have to do a calculation there later. But if the height is actually given to us on the edge or on one of the faces, we're good to go. So if we look here, yeah, the height was given to us along the edge here, and it says it's 16. So the area of any one of those triangles is the base, which is 24, times the height, which was 16 on that triangle, divided by 2. So if I do that calculation, I get 192 square units. The nice thing here, every other side on this pyramid is 192 as well. They're all the same triangle. So to find the surface area of this pyramid, we just add up all of those sides. So 192 4 times and a 576 gives us 1,344, and in this case, square meters. So the surface area of this pyramid is 1,344 square meters. Now the one down here is virtually the same example, except now, as we mentioned, if we look again at the size, or sorry, the height, the triangle does not have a height given to us on the outside. The height is actually the height of this pyramid in the inside. But if you look at what it actually makes here, we can see that this is a right triangle inside of there. So if I pull that right triangle out and look, it's 9 centimeters tall, and I need to figure out how far is it from here to here. But if you look in our pyramid, it's actually from this edge to the middle of the pyramid. So it's half of that distance. So that would be 12. So we have a 9 and 12 triangle. We have to find what this piece is here. That's the part that's alongside the triangle. This is called our slant height, which they refer to in this little gray box. The slant height is the height on the edge of the pyramid. So we can use Pythagoras here, which is a squared plus b squared equals c squared. So that's 9 squared plus 12 squared equals c squared. Now, if you look on our calculator, we'll do these calculations. 9 squared plus 12 squared, 12 squared equals 225. 225 is c squared. So to find that last side from grade 9 and 10, you should know I need to square root 225. So if I square root 225 on my calculator, the square root of 225 is 15. So this distance is 15, which means on our triangle, the slant height, or the height there, is 15. Again, we still have 5 sides that we're going to find for the surface area of this pyramid. And again, we'll start with the bottom. It's a square. It's 24 by 24. And we know that from our last example to be 576. Now we got to concern ourselves with the triangles that are on the edge of this pyramid. And I'm just going to redraw it. So here's the triangle. All 4 of those triangles are the same. We have a base of 24, and we calculated this height to be 15. So it's base times the height divided by 2. Base times the height divided by 2, that's 180 square centimeters, which all of those other triangles are also 180 square centimeters. So if I take the sum of all of those sides, I have 180 4 times and a 576. That gets me to 1,296 square centimeters for the surface area of this pyramid. Now again, this pyramid was a little different because we had to find the slant height. It wasn't given to us, but we used Pythagoras to find that out. The last example looks a little bit more complicated. It's a pentagonal based pyramid. So it's sitting on a pentagon, and it says the size of the pentagon are 18 centimeters and the slant height of the triangles is 28. So again, if we look at the diagram, it actually tells us that this slant height on the edge, since we're doing surface area, we need dimensions on the edge. This is 28 and the base is 18. These do make a right angle, so we have the base and height of our triangle. But now we got to read the question from this comma on. What is the exposed area of the pyramid? Exposed area says, what's the stuff that you can actually see? Well, we can't see, if this was sitting on a table, we can't see the bottom. So we don't need to find the area of the pentagon on the bottom, but what we do need to find is all those triangles around the edge, which we gave the term lateral area. So we're trying to find the lateral area of this pyramid. We don't need the bottom. So a pentagon is a 5-sided shape, which means I'm going to have 5 triangles around the edge, and I don't need to include the bottom. So this is only 5 faces. Again, to find the area of a triangle is base times height divided by 2. I have a base of 18, a height of 28, divide by 2. That's going to give me the area of one of those triangles, which is 252 square centimeters. But again, each triangle around the edge of this, each triangle makes up the lateral area of the pyramid, is 252 square units. So the complete surface area is just taking 252, multiplying it by 5, or adding it up 5 times, and I get 1,260 square centimeters. So surface areas of pyramids aren't too difficult, but we do need to, first off, make sure that we have the slant height. If we don't have the slant height, which is the height of the triangles on the outer side, or the height of the triangles that are making up the lateral area, we need to find it using Pythagoras. The second thing we have to consider always is this question asking us to find the surface area of all of the faces, or is it asking us just to find the surface area of the lateral faces, or the lateral area of the shape? It all comes down to how we read the question.